Hi everyone, my name is Benjamin, and in today's video I will show you how you can enable token extensions using the Token-2022 token standard. So in this video we are going to cover what token extensions and the Token-2022 token standard is, what the benefits are of using these token extensions, and eventually how we can apply this when creating our own token mint and token accounts. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so before we jump into the code, let's have a brief look at what this token extensions and this SPL Token 2022 library is all about. Token 2022 is the technical name for this relatively new SPL token program, also known as token extensions. However, the token extensions are the additional features that this new token standard enables, and you can think of them as a superset of new features that can now function at the token program level. Now, if you're familiar with the legacy token library, Token 2022 should be rather straightforward, as this new library supports the exact same instruction layouts as the legacy token. So you will see a lot of similarities between these two libraries, and often you just have to change the program ID once you are interacting with them. Now, according to Solana, with these token extensions, you can now create advanced, regulatory-friendly, versatile blockchain tokens that are fast to build, flexible, and meet the criteria that you need for creating enterprise applications. And for us developers, we can now rely on a native set of token features, and we do not have to rely on a mix of ad hoc protocols, code bases, and projects to enable this additional programmability. Finally, extensions are optional features that you can add when you create these token mints or token accounts. There are about 15 mint extensions and a handful of token account extensions, and in this video we will cover a few so that you can get started building using the Token 2022 library. And with that said, let's jump into the code. Alright, so this is our code base for today, and as a reminder, all the code will be available for download via our GitHub repository. And as you can see here, we have 4 files which we will use to demonstrate some of the features of the SPL Token 2022 library. Now we have create, where we will create a Token 2022 mint and token account for our primary wallet, and a token account is just an account that is owned by this primary wallet, and it will hold our tokens or the token balance for a certain mint. And of course, this token account will hold the balance for the mint that we are going to create. Now, for this token account, we are enabling the memo transfer extension, which will enable that all incoming transfers to this token account will require a memo to be included. Then we have mint, where we will create a supply of about 1,000 tokens for our created token mint, and we are going to send this supply to a associated token account from a secondary wallet. And a associated token account is similar to a regular token account. However, that token account is derived from the wallet address and also the mint address, and therefore our token account will inherit the extension immutable owner. Lastly, we have the transfer file, where we will transfer the tokens from our secondary wallet or secondary token account better back to our primary one. And to do this, we will need to attach a memo, as this first token account has the memo transfer extension enabled. And additionally, I'm also going to show you an example of a token mint creation where we will apply the transfer fee extension, which enables automatic fee collection on every token transfer. Now, to do this, we are going to use localnet as our cluster. However, you can also do this on devnet and even mainnet. Of course, you will have to pay some SOL then. And to start that local cluster, we are going to use Surfpool, which is a local development tool that will start a local validator for testing our programs and our transaction. And it has a nice GUI and some additional features, which I will briefly show to you as well. And for today's video, we are going to use Solana Kit, which is the rebranded version of Solana Web3GS version 1. And if you want a more in-depth introduction into Solana Kit, you should check out our previous video where we did just that. And with that said, let's check out our first file, create. Alright, so as you can see, the first thing that we will do is create a RPC connection and a RPC subscriptions connection. And remember, we are using Solana Kit, and this is similar as creating a new connection in Web3GS version 1. As you can see here, we are creating that connection using localhost because we are using a local validator. And that local validator is set up via surfpool. And we can really start that really easy by typing surfpool start within our Solana CLI. Now, if you want more information about the Surfpool CLI or Surfpool in general or the Solana CLI on how to set it up, you can refer to the official Solana documentation under installation, and there you will find both information for the Solana CLI and also Surfpool. Now, once you have set it up, you can use it to create a local cluster on your local machine and also create these connections to interact with it. Now, the next thing that we will do is create a key pair signer, and for that we have a function called load signer from file. And if we have a look at that, this function is declared here under wallet in the index.ts file. And what this function will do is just look at a private key that we have stored here under ID, and then it will derive that key pair from that private key. And these private keys, of course, you can use. However, don't put any real funds in them as they are available to everyone. However, you can use these key pairs to create the mints, to create the token accounts. And that's what we do here with that function load signers from key pair. So as you can see here, we can provide which wallet or which key pair that we want to recreate from these private keys, and then we will return it as a key pair signer. Remember, you can also change this with your own private keys. However, for simplicity's sake and for the purpose of this video, we can use these accounts or these wallets here. So once we derive that key pair from that private key, we will return it back to our main function and we will store it in the authority variable. And then in the remainder of our script, we can use this authority to sign, because this is now a valid key pair for our primary wallet that starts with VS1, as you can see here. Alright, so now that we have a RPC and a RPC subscriptions connection pointing to our local cluster, and we have a valid key pair signer called authority, we can continue with creating our actual token mint. And our token mint will need an address. And that address we can create by using the generate key pair signer. So this will create an account for us. And remember, everything in Solana is an account. Now, as our mint address needs to be on Curve, there will be an associated private key. And that is why we can use this function to create an account for our mint. Next, we are going to calculate the space, and we can do that by using the get mint size. And this will return to us the actual size of a default mint without any extensions. And then we store that within the variable called space. Next, we are going to create the account instruction that will create our mint account. And for that, we can use the get create account instruction. And we have to specify the payer, which is the authority. The new account is the mint that we created. And we will also have to make sure that this account holds a certain amount of LAMP ports to make sure that this account is rent exempt, meaning that this account can live on the Solana blockchain without having the risk that it will be removed. Now, in order to do that, we can use the method get minimum balance for rent exemption that comes with the RPC connection. And here we have to provide the space. And this will return us the amount of LAMP ports that is needed to make sure that this account is rent exempt, and then we will store that within LAMP ports. Next, we will specify the space once again, and also the program address. And the program address is the program ID from the Token-2022 program. Now, this also is imported here on top, and you can see that it comes with the Token-2022 library. And if you hover this, you can see the actual address. Next, we have to initialize our mint, and we can do that by using the get initialize mint instruction. And also this is imported here on top. You can see it comes with the Token-2022 program library. Here we will have to provide our mint address, and this is the mint that we created. We are going to provide the address, the decimals we will set to 9, and we will provide the mint authority and the freeze authority. And the mint authority will be able to mint more supply for our token, and the freeze authority can of course freeze token accounts associated with our mint. Next, we are going to create a token account for our primary wallet for our authority that will be associated with this mint and will hold the mint balance for us. And also here we can use the generate key pair signer function because this will create an account for us. Next, we are going to create a extension called memo transfer, and we can do that by using extension and then provide the memo transfer name here. And we will also have to set require incoming transfer memos to true, meaning whenever tokens will be transferred to this token account, it will require a memo instruction. Next, in order to create this token account, we will also have to create and initialize it, and we will also need the token size for that. Earlier we used the function getMintSize. Now we are going to create a token account, so we are going to use the function getTokenSize. And this time we are also going to provide that extension that we created here earlier, because the size now will be a bit bigger because this token account will include that extension here. And that's what we will do here. We will provide the extension that we created here, and that will then be calculated within the token size that will be used to create this actual token account. Next, we are going to create the token account instruction. Once again, for that we can use the get create account instruction. We provide the authority, which is the payer, the new account, which is the token account that we created here earlier, and then also once again that lamp ports, which is needed to make sure that this account is also rent exempt. Now, the only difference here is that we need to provide the actual size including that extension, and that size we calculated here earlier, including that extension that we also created here. So now this will return to us the amount of lamp ports for that token account, including that memo extension. And also here we will have to provide the Token-2022 program address. Next, we are going to create the instruction to initialize this token account, and here we can provide the account itself, so the token account address, the mint address, and also the owner, which is the authority. And finally, we have to create the instruction to enable the memo transfer instruction, and we can do that by using the get enable memo transfer instruction. And here we provide the token account for which we want to enable this, and also the authority, which is our authority here, or the owner, which is our authority here. So now that we have all the instructions created, we can create a transaction message. But first, what we do here is get the latest block hash, and also that we can do by using the method get latest block hash, which is available to us via our RPC connection, because this will later be needed to include in our transaction message. And the transaction message we can create by using pipe, and this is an easy way to allow us to create that transaction message by chaining all these functions and these instructions that we created earlier. So what we will do here is create a default transaction version 0. We are going to specify the signers, which is the authority, and also the latest block hash, which is the latest block hash that we just got here back from our RPC connection. And we are also going to append some instructions, of course, and these are all the instructions that we just went through and created here that we are now going to append to this transaction message. Now, once we have the transaction message, it needs to be signed, and we can do that by using the sign transaction message with signers function. And this will sign the transaction message for us with the included signers here, which is in this case the authority. Next, we can take that signed transaction and we can send and confirm it. Now, as you can see here, I have one step in between, because if I just provide this signed transaction here, it throws to me some kind of TypeScript errors. So what I had to do is narrow down the type by spreading the signed transaction here, and also provide the lifetime constraint value and setting it to the latest block hash. And then I could take this transaction to send and provide it to the function here, send and confirm transaction factory, which will send for us the transaction and also confirm it using the RPC and RPC subscription connection that we set up earlier. And then we provide that transaction sent object that we created here, also the commitment, and we set skip pre-flight to true, so it will not try to simulate this transaction for us. Next, we are going to take the transaction signature by using the get signature from transaction function, and we are just going to provide our signed transaction here once again. Now, once we run this and everything went well, we will have a mint address, a token account with the extension, and also the transaction signature, and that is what we log out here. Now, before we can do that, we need to make sure that our primary account has some SOL to make sure that we can pay for this transaction. And here in the README, I have all the addresses from the accounts that we are going to use. So if we go back to our surf pool, as you can see here, there is a feature that we can use to airdrop some Solana within these accounts. So we can use our primary wallet, which is VS1. And if we go back to our code base, we can also take our secondary wallet. And also here we can add that wallet and airdrop it some SOL. So if we set 100 SOL, this will be airdropped within these wallets. As you can see here, you can add multiple wallets, and if you don't want to use these wallets, you can just use a wallet that is generated here for you. So once we click on send, it will send that SOL to these accounts. Now, if you do that for a account that you don't provide, you can click this icon here, and if you then send SOL, you will see that it also sends the SOL, but you can download the key pair. And if you want to do so, you can store that key pair here if you don't want to use the key pairs that we provide here. So that is also an option that you can do. All right, so now I opened both of these accounts that we will use here. So the VS1 account, and you can see it has now 100 SOL. And the VS2 account, which has also 100 SOL. And now that we know that this account has SOL, it should be able to do these transactions and make sure that they go through without any error. So if you run this script and you see that you run into any issues, you can always check that the accounts that you're using have at least some SOL to pay for the transactions. And remember, I can inspect these accounts because we are connected to our local cluster here. So make sure that you also change this to your custom RPC URL. Now, if we want to run this, we can just type npm run create, because within our package.json file, we specified this command here, and create will point to our 01 create.ts file. And if we then run this, you will see that we get back a mint address, the token account, and also the signature. And if we go back to surf pool as well, if you refresh, you should also see that transaction here now. And this is really great about surf pool because we can actually check out all these instructions that we created, and we can dive deeper into what happened. And we can also check out if something goes wrong, and we can also inspect that within our explorer here. Now, if we go back, this is our mint address now. So we can really drill down into this instruction that we just did. If something goes wrong, we can also check out what went wrong. So this is really great with surf pool. You have really good visibility for all the transactions that you're running against your local cluster. If you would look at our created mint now, also that we can open here. And then you can see that this is our unknown token, of course, but we have a token 2022 mint, and the freeze and mint authority is set to our VS1 wallet, as you can see here. But as you can see here, we have no supply, but we will take care of that in a minute with our next script. But if we go back to our primary wallet, the VS1 wallet, under tokens, you can now see that we have that token account that was created. So if we click on details, you can see that this is the mint address. Remember, the actual mint here. So the mint starts with 8E, so we can copy this. Then we can also have a look here. That is actually the mint that is associated with this token account that we created here. And if we click on this token account, you will see that we have the memo transfer extension enabled. And also here we can click on extensions and we can expand this. And here you can see for these token accounts, in order to receive transfers or tokens, it will require that memo. So you can see that this extension is enabled on that token account that we created. And the next thing that we can do now is actually mint some tokens, send that to a secondary wallet, and then we can try to use that secondary wallet to transfer the tokens into that first token account. And we can check out if we can do it without a memo message, which is highly likely not the case. And then we can try it with a memo message, and then we will see that it goes through. And that is what this memo transfer extension takes care of. So with that said, let's check out our second script called mint.ts. Alright, so the next thing that we're going to do is create some supply for our token mint and send that supply to a secondary wallet, which we are also importing here on top by using the same function as before, the load signatures from file. And here we provide VS2, which is our secondary wallet. Next, we can take that mint address and also provide it here to make sure that we are working with the correct mint. So once you created your mint, you will also have to provide that address here. Next, we are going to create or find that associated token account from that secondary wallet. And remember, a associated token account is just like a regular token account. The only difference is that it is derived from the mint and the public key address from the owner itself. And also here we have to provide the token program address. Next, we are going to create that associated token account. The payer will be the authority. And as you can see here, we specify that mint and the owner, which is our recipient. Next, we are going to create that mint instruction, and the mint that we will provide is of course the mint that we set here earlier and created here in the created.ts file. The token is the recipient associated token address that we found here earlier by using the find associated token PDA. Next, we are going to create the instruction to mint the tokens, and here we will have to provide the mint, the token which is the recipient associated token address, the mint authority, which is of course authority, and we can specify the address, and also the amount of tokens that we want to mint and that we want our supply to be. Now I have a helper function here called tokens to raw, and what that will do is just transform the actual amount of tokens that we want to mint, including the decimals that we specify here. So we will get a big int that will be returned to us, and then we can specify the actual amount that is needed to make sure that we mint 1000 tokens. And we can use the get mint to instruction function for that. Now also that function is imported here on top. As you can see, it comes with the Solana program Token-2022 library. Next, once again, we fetch our latest block hash just as what we did before, and we are going to create once again a transaction message. And here we use pipe once again, creating a empty transaction using version 1. And we set the signer, which is the authority, the latest block hash, and our two instructions, the create recipient associated token account instruction and the mint instruction. Also here we will sign that transaction using once again the sign transaction message with signers. And then once again we narrow down that type so that we can use that type here in the send and confirm transaction factory. And that's what we do here. So that transaction to send, which includes the signed transaction spread and the lifetime constraint, which is our latest block hash. And once again then we provide it here, and then we set the commitment to confirmed. This time we wrap it in a try catch statement, and we see if it returns to us a Solana error, and we can do that by using the is Solana error function. This also comes with Solana kit, and what this will do is just check if there is a error returned, if it is a Solana error, and we can also provide here the type of Solana error that we want to look for. So if our block height has been exceeded or our latest block hash is no longer valid, then it will throw a Solana error, and then we can also capture it and output that nicely here. Otherwise we will just throw a random error. Next, we are going to also fetch that signature by providing the signed transaction and using the get signature from transaction, and output that signature here within our console. So if we run now npm run, and this time we type mint, that will mint the tokens for us. And as you can see here, we have a transaction. And if we go back to serve pool once again, you can see here also that transaction displays exactly what happened here. And we can click on view, and that will open the transaction once again for us in our Explorer. And we can go through all the details here or within serve pool. That's what you like. Now, if we go back to that actual token, so this was the token mint that we created, we can now see that we have a supply of 1,000. And if we go back to our secondary account, so if we refresh here, the secondary account is the VS2 account. If we go to tokens now, you can see that we have these 1,000 tokens because we minted them and we send them to our secondary account. So also here, if we click on detailed, you can see the associated token account, because if we click on that, here you can see that this token account, which is a Token-2022 account, now has the immutable owner extension. And if we look at extensions, also here we can expand this. You can see that it says here prevents the owner from being changed, and that is because we created that associated token account and we sent here these minted tokens, and then it inherits this immutable owner extension that comes with the Token-2022 account. Alright, so now we know that we have a supply of 1,000 tokens, and these 1,000 tokens are held in a token account which is owned by our secondary wallet. The next thing that we are going to do is send these tokens, or a portion of our tokens, to our VS1 wallet, which is our primary wallet. As you can see, we also have a token account, but it has 0 tokens. And this token account, remember, has the memo transfer extension. So in theory, we can send these tokens from the secondary wallet to our primary wallet. The only thing that we will have to do is make sure that we provide that memo instruction. And that is what we are going to do here in the third script called transfer.ts. Alright, so let's have a look at this transfer.ts file. So also here we can provide our mint address, so make sure that we are working with the correct mint. So again, if you created your mint, don't forget to provide your mint here. Now this time we are going to create the keeper signers once again from the secondary wallet and the primary wallet. And the secondary wallet will be our sender and the receiver will be our primary wallet. And then we store it in sender and receiver, and we also have our mint. Now the first thing that you see here that we are going to do is find that associated token address from our actual sender, and we do that by using find associated token PDA, and we provide the mint, the sender address, and also the program ID, because that is the token account that we are going to send the tokens from. Now next we need to find the token account that is associated with this mint for our receiver. Remember, we are not using a associated token account, we are using a regular token account, so it cannot be derived the same way as we do for our sender. Now in order to get that token, what we can do is use our RPC connection and use the get token account by owner method. And this is just a regular RPC method from Solana that we can use to get these token accounts for this receiver, so for the wallet from our receiver and for the program ID that we specify here. So it should return us all the token accounts that are available for that receiver's wallet for this Token-2022 program. Now, once we receive all these token accounts, we need to make sure that we find the right token account, and we can do that by using the find function based on all the token accounts that have been returned to us. And we need to just make sure that the token account matches the mint that we are looking for. And if that is the case, then we are going to store that token account within the receiver token address variable. Now that we have both token accounts, both for the sender and for the receiver, we can continue and actually create the transfer instruction. And that we do by using the get transfer checked instruction function. And what we do here is specify the amount, and we can use the same exact helper function as before, the tokens to raw, and here we provide 100. So it means that we are going to transfer 100 tokens from our secondary wallet to our primary wallet. The source is our sender associated token address, the one that we have here. Remember, our secondary wallet token account, and the destination is the receiver address, the one that we got here by using the get token accounts by owner. The authority is of course the sender because we are sending from our secondary wallet. The mint is the mint that we of course created here earlier, and we have to also specify the decimals. Remember, all these functions, they come imported via the Solana program token 2022 library, and they might look similar to the actual token library, but you need to make sure that you import them from the correct token 2022 library. Now, once we have that transfer instruction, we also have to create a memo instruction, remember, because we cannot transfer these tokens without having a valid memo instruction, and that we do by using the get@memo_instruction function, and we just create a simple memo saying required message Solana Vibe Station transaction. Now, once we have these two instructions, we once again get that latest block hash and create our transaction message using pipe. So once again, we are creating a empty transaction using version 0. We specify the sender as the signer this time, the latest block hash, and also we append our instructions here. The memo instruction first, because it is really important to make sure that we send this first, and then the actual transfer instruction. And once again, here we are going to sign that signed transaction, and also here we are going to narrow down our type by spreading the signed transaction and specifying the lifetime constraint. And then once again, we are going to send and confirm this transaction using the send and confirm transaction factory, which comes with Solana Kit. We provide the transaction to send, and also here we are going to see if we receive a specific Solana error, and eventually we are going to fetch the signature using the get signature from transaction function and providing our signed transaction, and also output that here. So what we can do now is also run this npm run and then transfer, and that should transfer these tokens, and we should see a valid signature here. And once again, if we go back to serve pool and we close this and we can refresh here, that should be that instruction or that transaction that sent these tokens from one token account to the other. If we go now to that secondary wallet and we refresh, you will see that we no longer have this 1000 tokens, but we have this 900 tokens here. And if we go back to our primary wallet, we no longer have this 0 tokens, but we should have at least 100 tokens. And as you can see here, we now have 100 tokens. Now, to make sure that this won't work without specifying the memo, what we can do here is actually going back to our pipe function here and remove that memo instruction. So we are going to do the exact same transaction, but without the memo instruction. And if we run this once again, you will see that we get an error, and that error says here no memo in previous instruction. So we know now that the actual token account is set up with the proper extension and that it requires a memo instruction to be sent along. Alright, so now to conclude this video, I want to drive home one last point, and that is, if you look at these token accounts, you will see that this extension is applied on the token account. And earlier in this video, we discussed that these extensions can be applied on token mints and on token accounts. So if we look at our actual token mint, you will see that it has no extensions. You see, no extensions have been found. And that is because the extension is applied on the actual token account. Now, I added an additional file here that says create fee, and what this will do is create a token mint once again, but this time it will apply a extension on the token mint. And you can go through this code. It's quite similar to the first create file that we had here. However, now it will apply a extension on the token mint. So what you can do now is type npm run create fee, and you will see that it also creates a new token mint for you. And also here you can see all the details. So mint address with transfer fees. And you see the token accounts that have been created. So it has a similar approach as the original create functionality. However, now it applies a extension on the token mint. And we can also have a look at that. So if we look at this token mint here and we go back to our explorer and we paste that mint, you will see now that we also here have a token-22 mint. And this is our original token-22 mint without an extension here, as you can see. And this is the new one. And here it says transfer fee config. And also if we click on extensions, you can find more information. As it says here, allows a fee to be set aside on every transfer that can only be withdrawn by the withdraw authority. And also the actual parameters for the fee amounts that you want to extract. Now, all these parameters, they are set within this code here. So if you click on that, you can specify an actual fee config. And that is what you do here. As you can see, you create an extension, which is called transfer fee config. And here you set the parameters for that. And then that extension can be applied on the token mint instead of the token account. Now, it's really important to remember, as we discussed earlier in the video, that there are extensions both for token mints and token accounts. There are less extensions for token accounts and more for token mints, but it's good to know that you know where to look once you apply these extensions on token accounts or token mints. So I hope you now understand how you can apply these extensions on token accounts and token mints and how they actually add additional functionality to both these token mints and token accounts. Remember, the code is available for download via our GitHub repository. So if you don't want to code it all yourself, you can just download the code and go through it. However, I hope it was informative. And with that said, I hope to see you in the next one.